Once again, keep in mind we do jump around this chapter quite a bit. We are already on 4-7, and we just started chapter 4 the other day. So we're doing, just today is just radical equations, is day 1. Day 2 will be the inequalities. The first one here is probably pretty straightforward. Most of you probably already know the answer to that one, but you wouldn't necessarily have done it algebraically. And as it's stated right here, the biggest part of solving radical equations is to make sure that whatever you do to one side of the equation, you do it to the entire other side, so it's both sides. You can't just pick and choose which terms you do something to. You have to either do it to each side. The only thing you can pick and choose your terms is if you multiply by 1. That's the only time you can pick and choose terms. But here you have to do it pretty much to everything. I think most of us know that 25 is the x value I had to put in there to make this work. But what you really want to do, and we'll start with a simple one. Algebraically, what you would want to do is isolate the radical is what they call it. So get that radical so it's the only thing on that side of the equal sign if you can. And it is, right? And then you got to get rid of the radical by doing the opposite, which in this case is squaring it, right? And so then square that one. Over here, I think those of you that had me for Algebra 2, that was called Housify. And so that side cancels, so it's x equals 25. Whenever you start squaring both sides, you really should start checking your answers all the time, because you never know when squaring could cause problems. What I mean by checking is actually put it back in. Substitute back into the original, and, well, it works. Okay? And then we'll do this next one, and then I have a few more I want to talk about at this first area here. Why is that one slightly different? The radical is not isolated. Can we isolate it? Quite easily, right? Add the 1, square root of x equals 7, and you square. Housify x is 49. Does it work if you substitute it back in? Put 49 right there, take the square root, you get 7 minus 1 actually is 6. So it checks. Now, before we go on, I want to make a huge distinction here. The difference between that and that. Would you say the square root of -8 and the cube root of -8 are the same? No. Now, what you really have to do is, if you're going to finish these, here's how you would take care of that. Because there is nothing that I can square to actually get 8, right? Nothing nice. Okay? And so you would take the square root of -1 times the square root of 4 times the square root of 2. Do you agree that's the square root of -8? Same thing? What is the square root of -1? Aye, very good. What's the square root of 4? 2. Square root of 2? 1.414, something like that, right? So you just leave it like that. So that's the answer to that one. So it's imaginary. So if you're asked to give real answers, what are you going to say for this? If you're asked to give all real answers, you're going to say this has none, right? It doesn't have any real answers. How about the cube root? Because remember, square root means take something times itself. And apparently, if I take 2i square root of 2 times itself, I'm going to get 8. Okay? Here, it's something times itself and then times itself yet again to get there. And so is there something that I can cube and actually get to 8? That's the question. If I take 2 and cube it, I do get to 8, correct? How about -8, though? If I take -2 and cube it, do I get to -8? That's the tricky part. Just think about that. -2 to the third means take -2 times -2 times -2, right? What's the first one? -2 times -2 is a positive. 4 times -2 is. So you see how cube roots a little different. So square roots, fourth roots, sixth roots, any of those, negatives on the inside going to end up imaginary. Third, fifth, seventh root, any of those, there's negatives inside, they're not really a problem. It's only squares and all evens. So just make sure you have that distinction in your head. Now back to what we're talking about today. Isolate the radical if possible. Well, the radical is x minus 4. It's a square root this time. It is not by itself. So isolate it. Subtract 5. So it's the square root. X minus 4 equals negative 3. Do you agree with that? Any questions about that? Is it okay that the minus 4 is inside the radical at this time? Yeah. I just say get the radical by itself. The radical can be huge, but you have to get it by itself. That radical is all by itself. It's on the left side. It doesn't have to be on the left side. It could be on the right side, but it is all by itself. And how do you get rid of a square root? There's an understood 2 right there, right? And you get rid of it by taking it to the second power. So x minus 4 equals 9. Very good. It is 9, right? Positive. And add 4. I think this is the answer somebody gave for the previous example. They were just a little ahead. Yes? What are you saying? Right, and the only time you put plus or minus on a square root is if you decide to take the square root. And did I decide to take the square root in this problem? No, it was given to me, correct? It was 5 plus that. It didn't say plus or minus. So the only one I'm supposed to use is the one I see, plus. So if I put 13 back in, you're trying to tell me it doesn't work? Well, 13 minus 4 is 9. Square root of that is 3. 5 plus 3 is not 2. So what happened? Well, if you could subtract 13, it'd be great. But I can't put negative 13 in. That'll make an imaginary root. So what happened? Well, what happened is right there. That negative got turned to a positive pretty much without having any say about it. Okay, and once it happened, it turned into a 9. So this has no real solution to this problem. Okay. You have to check. Should you have known at this step here before we did anything that it wasn't going to work? You had a positive square root equaling a negative number. Can you think of a number you can put in there that's going to give you negative 3? Because I can't. Okay. That'd be square root of negative 3, not negative 3. So check your answers and watch out for negatives. All right. This one's slightly different because it is minus this time, correct? And that's the only one I should deal with. So let's get that 7 out of there. Subtract 7. Now, that last problem, we had a square root equaling a negative, and it was no good, right? Because it was a positive square root equaling a negative. This time I have a negative square root equaling a negative. Does that at least have a chance? Yeah, that at least has a possibility. Now, watch out. When you square it, you have to take the entire side and square it. Entire side, square it. When you take a negative and square it, what's the end result? Negative or positive? Positive. And in this case, it's just pretty much a big old positive. X plus 6 equals 16. Subtract 6. X is 10. Once again, I haven't circled it yet. How do you know? You put it back in so it works? You sure? Let's find out. So that means put 10 right there. So 7 minus square root of 16 is 4 is 3. Is that true? Yep, that's true. Works. Okay. Here's a vocabulary word you may need as you go on to school. Extraneous. Really big word for extra, but wrong answers. Okay. And that's what happened on that one. we got extra answers. They aren't right. So, you seem very clever. So on the back, let's have you solve this one. Unless you actually have one on the back already, no? So why don't you give that one a shot? Everybody got that, so I can pause it? I'll give you a second. Let's hear a variety of, well, it'd be great if you all just had the right answer, but let's hear some answers out there. What's that? 53. 53? Did you put it in? Yes. Does it work? No. Yes, what else? Yeah. No answer? Okay. Negative 75. Wow, we have a variety. Does anybody have something different? Or is somebody all within those? No solution, 53 and negative 75? Negative 53, okay. All right, I chose this one on purpose because that negative does kind of cause some issues. What else is different about this one? Cube root, okay. So let's just try it, see what happens. I gave you some suggestions, right? Isolate the radical. Is it by itself? No, so subtract 3. So you get 4 equals negative that, correct? Now, some people don't like that negative, and that's fine. I mean, if you want to multiply by a negative 1 to both sides, it would take care of that, right? It'd be a positive cube root then equaling a negative 4. Doesn't matter. Does this even stand a chance of being possible? Yeah, it's a cube root, so it does. Okay, if it was a square root in there, no shot. Negative square root equaling a positive number? Negative cube root? Yeah, that's because that could be a negative answer. So I'm actually going to leave it, I think I'll leave it there. So let's see what happens. We got to get rid of a cube root, so look at the entire side has to get cubed. This side also has to get, well, 4 times 4 times 4 is what 4 cubed, right? 64, right? Are we in agreement with 64? Okay. Now when I cube this side, I'm going to take a negative times a negative times a negative, right? Which is negative.
Peterson, what are you doing?
Right? Because then the rest just house-spies. I think I see one of these answers happening. Right now you might see the 53 or the 75 happening. Okay. But what do you got to do with this negative? Distribute. So 64 equals negative x minus 11. Add 11. I don't want to know what negative x equals. I want to know what positive x equals. So divide by negative 1. X is, and I believe we heard that answer. Okay. Well, we haven't checked it yet, though. How do we know? Put it back in. So right here, negative 75 plus 11 is negative 64. Cube root of negative 64 is negative 4. So it's 3 minus a negative 4 is 7. Okay? Now, everybody's attention up here. What's an easy way to avoid that distributing the negative deal, though? Right here, just multiply both sides by negative 1, and then you don't have to worry about it anymore. You don't have to worry about distributing it. It's not there. It's over here. Okay. So any other questions? Okay, I wanted to show you that one so that if you saw one later, you might do it right.